All right, guys, so in this video, I'm going to go over real quick how you can determine what the limit is when you have a vertical asymptote. So in class, we talked about how if you have something that when you plug it in and it's undefined, so if I were to plug 4 in here, I get 4 minus 4, so I know, all right, it's 1 over 0. I know this function is actually undefined there. I can't factor, I can't simplify, I can't do anything algebraic to this equation because it's already simplified as far as it can. So what we know about this function, we know that this is our rational function. And I know that since nothing cancels out with that x minus 4, I actually know that I have an asymptote there. Okay, I also know that because this is a rational function, it also is going to have a horizontal asymptote at 0. Okay. Now, based on our little beautiful dance moves or our function families, we know that this function is actually going to look like this. Okay, now you might come across rational functions that you don't know as well what they look like, but for our basic rational function here, we know what this looks like, and we know that there's a vertical asymptote at x equals 4. So that's what this tells me. Vertical asymptote at x equals 4. So I know anytime I have a vertical asymptote, automatically my limit does not exist. Okay? Now, because this limit doesn't exist, we're going to go a little further into analyzing this, and I actually want to talk about what if I asked you for the one-sided limits here? What if I asked you what's happening from the left or what's happening from the right, and you don't have the graph to look at? So let's talk about that. If I do the limit as x approaches 4 from the left, okay, so I know right now, before I even graph it, I know that I have an asymptote right here at positive 4. Okay, and because I have an asymptote, I know that from the left, it's either got to be going up or it's got to be going down. Okay, I might not be sure which one it is every single time. So we're going to talk about what to do when you're not sure. So I know there's an asymptote. It's got to be going to infinity. I'm going to take a number right here, and I'm going to plug in from the left, has to be a smaller number. So I'm going to plug in when x is 3. Okay, make sure that you do not do this, because that is not a true statement. Okay, if you're ever going to do scratch work, go over to the side and do your scratch work. So 1 over 3 minus 4 is going to be 1 over negative 1, which is negative 1. So I'm going to assume, okay, this graph might be going down to negative infinity. Let's pick a point that's even a little bit closer. Let's do 3.5. Okay, so 3.5 minus 4 is going to be 1 over negative 0.5, right? 1 over negative 0.5 is going to be negative 2. So it's getting down even further. So we're going to assume that this graph is going to continue as it gets closer and closer to 4 from the left. We're going to assume that that is going to negative infinity. Okay, so using our knowledge of asymptotes and by just plugging in points that are really, really close to it, it's almost like we're making a little XY table. We're going to see that this function is actually, I plugged in 3 and it was negative 1. I plugged in 3.5 and it was negative 2. Okay, you could keep going and get closer, closer, closer to 4, and you're going to see that this number is just going to keep getting more and more and more negative. Okay, now let's try this from the other side. Okay, if I approach it from the other side, let's try plugging in some numbers that are bigger than 4. So I'm going to do 5. Oops. Gives me 1 over 1, which is going to be 1. So coming from this side, let's change our color. Coming in from this side, all right, well at 5, I know that it's at 1. Let's try a number that's a little bit closer. Let's try at 4.5. So that's going to give me 1 over 0.5, which is going to give me 2. So as I come in here closer, it's going to be going up. So we know that this graph is going to be getting closer and closer and closer to positive infinity there. Okay, so whenever you have an asymptote, you know that it has to be does not exist, but we do have to take that extra step to go and see how does it not exist. Is it going to be going to positive infinity, or is it going to be going to negative infinity? Because sometimes you might find out that both sides are going the same way. And if both of the sides were both going to positive infinity, you could then say that the overall limit is to positive infinity as well.